Okay, this is our vector diagram, and we've got OP is vector P, OQ vector Q, P and Q, and PY is K vector Q, and I've got PX. This here is 1/3 of PQ. I need to express the vector PX. Well, the vector PX is not very difficult, so what we're going to do is just say PX is equal to 1/3 of vector PQ. So that means 1/3 of vector PQ is PO plus OQ. In other words, we're saying 1/3 into minus P plus Q. So you can say 1/3 Q minus P if you want. And that's the answer. The second part, I need to find the vector OX in terms of vector P and Q. So we're going to look at the diagram. OX is here. So OX is OP plus PX. So what are we saying then is vector P, because OP is vector P, plus PX, and PX is found to be 1/3 Q minus P. Minus 1/3 P. So 1/3 vector Q minus 1/3 vector P. If you do that, P minus 1/3 P is 2/3 P. So I've got 2/3 P plus 1/3 Q. So this is my vector OX. Next is we need to find the vector QY in terms of K, vector P and vector Q. So QY is this. QY here. Let's find QY. So we know that QY is QP plus PY. So QY is equal to QP plus PY, as we've seen. So what is QP? QP is the opposite of PQ. And we found PQ was PO plus OQ, that is Q minus P. So that's going to be then P minus Q. Opposite is P minus Q. Plus the vector PY, and PY is given in the diagram as PY is K vector Q. Alright, so we're going to add K vector Q plus K vector Q. Now what we can do with this is very easy now. So P into this here is K. The coefficient of Q is K. Coefficient of Q is minus 1. So I can place KQ minus 1Q. In other words, we're saying vector P plus the Q and Q is common. I got K minus 1 inside. And here we are. That's the vector QY. Now we also need, we've been given that OX is parallel to QY, find the value of K. OX is parallel to QY. When two vectors are parallel, let me just write this down. Okay, OX is parallel to QY. Therefore, I'm going to say OX multiplied by some constant H is equal to QY. So what we make of this is that OX times H. What is OX? OX is 2/3 P plus 1/3 Q. So I'm going to say 2/3 P plus 1/3 Q, and all of that times H is equal to QY, and QY is just found to be P plus K minus 1Q. Now we see that the coefficient of, we're going to equate coefficient, okay, so we're going to equate coefficients of vector P and vector Q. And what do you have a vector P here? Vector P here has got 2/3 H. So 2/3 H is equal to vector Q. P here rather. So P is 1. So 1. So in this case I've got then H is equal to 1 times 3 is 3, and that's 3/2. That's H. But we've been asked to find K. What's the coefficient of Q then? Alright, we've got coefficient of Q as 1/3 H. So I also got 1/3 H is equal to, and the coefficient of Q here is K minus 1. So this is K minus 1. So 1/3 times H, that means 1/3 times 3/2 is equal to K minus 1. The 3 and 3 can go, I've got half. So K is equal to half, and the 1 can come on the other side and plus 1. So that means K is equal to 3/2 as well. So here we are for part 4. Now for the last part of the question, what I've done here, I've drawn a line from x to z because this line of x is produced, meets py at z. So we need to find pz in terms of q. The first thing I would like to do is let us see what pz is all about. So pz, this part here is po plus oz. So pz is equal to po plus oz. And that basically is minus p plus oz. Now what is oz? Now oz has to, if you want to find oz, because z lies on the same line as o and x, so ox times h is equal to oz. And we found that h was 3 over 2. So we know that this is going to be then 3 over 2 times ox. So minus p plus 3 over 2 times ox, and we found ox in the second part was 2/3, okay, vector p plus 1/3 vector q. So we got then minus p. 3 over 2 times 2 over 3 is 1, 1 times p is p. Then 3 over 2 times 1 over 3 is 1 over 2, and you've got q with it. And this disappears, and I'm left with pz as half q. So this should be the answer then. Take care.